Okay, I think we're good to start. Hi, and welcome to our webinar today, to the roundtable discussion on biogenic CO2 from biogas with CCU, carbon capture and utilization. My name is Lisa Altubaya. I'm very honored to share this space with these three gentlemen here and get their perspective on the topic. Let me introduce very quickly. So we have Julian Beatty, Managing Director from NovaQ. Julian is a technology and market expert and is here today to give us insight on different technologies and quality requirements for biogenic CO2, as well as market and regulatory updates and outlooks on future developments. And we have Dr. Reinhard Klimek. Reinhard is the Vice President. Hi. The Vice President for New Products and Transport at Nature Energy. Nature Energy is Europe's biggest biomethane producer. And he will talk today from the perspective of a biogenic CO2 producer. Will let us know their current activities, challenges, outlook on future developments. And last but not least, of course, Fabian Floto. Fabian is the CEO and co-founder of Internal Power, a globally active hydrogen and e-fuel producer. And he's here today to speak from the off-takers' perspective, since they need for their production quite a lot of biogenic CO2 or CO2 in general. The activities, purchasing the bio CO2, future plans, challenges, and general thoughts of this topic. Welcome again. Hi. Nice to have you here.
Thank you.
Great to have you here. The agenda for today is we all give you a short background information of who we are and what our involvement is with biogenic CO2 and its use. Then we will have a hopefully very interesting and, of course, engaging discussion on the topic, and then leave enough time for the audience to ask questions. You can ask questions, and you can do that also, of course, throughout the discussion in the chat. Just write it down, and we will go through it towards the end of the webinar. You will then also see a book a meeting link, and this is a book a meeting link or a meeting with me. But if I'm happy to include, if you let me know with whom you want to talk, I'm happy to include any of the three panelists. Of course, you can also write them directly in their presentation. You will see their email addresses, and contact them privately. So our aim for today is to give you more knowledge about the current status of the biogenic CO2 market from biogas, current production and off-taking activities from two big players, a big producer and a big buyer, of course, and insight into market outlooks regarding regulations and certifications, and also, and this is my part, future trading possibilities in the sector. My name is Lisa Altubaya. I am the Senior Energy Climate Solution Manager at Go-to-Markets, Green Gas at Go-to-Markets, and I'm mainly active on biomethane Europe-wide, but also in the US. Of course, other green gas products are just picking up, and I'm also taking care of that. My role today is to moderate this discussion. And my personal angle to this topic is the circularity. It's bothering me since years that the CO2 from the upgrading process from biogas into biomethane is wasted, and most of the time blown in the air. And yeah, I'm very happy that I see movement in the space, and hope to be very active in this topic. Two words about Go-to-Markets. Go-to-Markets is a trading house on renewable energy commodities based in Berlin. We are around since more than 10 years. We have a very strong trading team in Europe, but also in the US, with native speakers constantly building our renewable energy network of producers and off-takers. We work with many energy companies, cities, corporates, of course, and we work very closely with our counterparts. and help them to find sustainable energy solutions across the board and for different commodities. We also have an in-house advisory service to help corporates to become carbon neutral. And yeah, you can have a little look. These are our services and our products we mainly cover. Maybe another word, we are, as I said, traders, but we also, in some cases, we act as brokers because it makes more sense to put both parties on one table, especially when it goes for long-term offtake. Just a few numbers of what we did in the past years regarding renewable energy. Of course, most active we were, we were in renewable energy, renewable power, but also biogas, my topic, green gas, white certificates, especially in France, and carbon offset projects. Okay, that's it from my side. I would like to hand over to Julian from NovaQ. Julian, please.
Good morning or good afternoon, everybody. Thank you, Lisa, and thanks to Go-to-Markets for inviting me to take part. Go to the next slide. So as Lisa said, I'm the Managing Director of NovaQ. We're an environmental sustainability solutions company based in Dublin. We're celebrating 15 years in business this month. Our business model is based around new and emerging potential best available technologies, always in an environmental space, and we operate in water and wastewater, recirculating aquaculture, agriculture, and most relevant for today, renewables and anaerobic digestion. The next slide, please. Specifically for biogenic CO2, we have been working closely with our partners, Hydrus Renewables and Promethean Particles in England, Innovatium in Scotland, to develop what we believe will be the next generation of biogas upgrading technology. When we started this journey with Hydrus, we asked ourselves, what would the ideal biogas upgrader look like? High quality biomethane, high quality CO2, liquefaction, and all of those are a given. But also low methane bleed was very important, low parasitic load was very important, and not having a hazardous waste as well. Our solution, which goes into testing in the next couple of weeks, delivers all of those thanks to the unique properties of metal organic frameworks, or MOF, as is known in the chemical industry, these MOF particles, they allow our system to work at both ambient temperatures and low pressures. So it's kind of an exciting development. It's also a plug-and-play solution, and over the next few weeks we'll get a really good idea about just what level of purity of CO2 we can get from the gas stream, which will then lead into CO2 liquefaction. I'd also like to acknowledge the slide is slightly distorting. The innovation funding is from Gas Networks Ireland, so I'd like to just acknowledge their support in helping fund this project. Next slide, please. So whilst developing all of this work, I also personally got involved in the Biomethane Industrial Partnership, which, for those of you who aren't familiar with the BIP, it was founded by the European Biogas Association and the European Commission and the member states. And it's specifically to get an industrial perspective or input into the whole biomethane industry and how that might evolve going forward. Personally, I got involved in Task Force 4 and 4.1, where we're looking at business cases for the various byproducts of biomethane production. We're currently working on a report on emethanation, but in April this year, we presented our first report, which focused on biogenic CO2 from biomethane production and the business case for that. There was a great group involved. and probably the highlight of the whole process was a workshop that we did in Brussels of about 14, 15 people. At this workshop, a few of us were asked to do a bit of research beforehand on the various use cases for biogenic CO2 in CCU, carbon capture utilization, CCUS, looking at utilization and storage, building materials, and CCS in carbon storage. In my case, I was looking at e-fuels and carbon capture and utilization. And one of the cases that stood out for me on this whole thing was e-methanol for shipping, where, you know, one example was in the new dual fuel container ships, these massive container ships that travel from China and the US and so on. One of those vessels will require 200 tons of e-methanol a day. Each ton of e-methanol needs 1.5 tons of biogenic CO2 and 200 kilos of hydrogen. So that's 300 tons a day just for one of those vessels. And it's estimated that there will be 1,200 of those vessels by 2030. So the demand is you know, that's just one use case, and it's pretty significant. So the next slide, please. So what became clear throughout this whole process and is evident in this report, I've taken a few extracts from the report, but the report itself is available online. The role and future demand for biogenic CO2 has been either underestimated or in some cases even ignored. The report, which is really well referenced thanks to the great work by Case and Leo in Common Futures, it highlights that when you put it all together, the likely future demand of biogenic CO2 alone will be many times more than the current CO2 market. Next slide, please. So, I mean, the current CO2 market's only 41 million tonnes, or in 2022 was 41 million tonnes. And important to note, in that 41 million tonnes, there's only about 4 million tonnes of that is what they call the formalized market, which is liquid CO2, which is just a little bit under 4 million tonnes. So when you put that into the context of, if you just go back one slide for a second, sorry. If you put that into the context of the potential demand there, which is measured in hundreds of millions of tons, it really is. It's very, very, very significant. Sorry, if you go forward 2 slides, please, Lisa. Sorry. What was also noted was that the biogenic CO2 from biomethane is increasingly cost competitive, and it has a very high growth potential. Remember that CO2 coming from biomethane production, it's concentrated. It's typically greater than 96% CO2. Yes, it's about 40% when combined with the methane in biogas, but when you've upgraded to biomethane, your CO2 fraction is usually greater than 96% and often over 99%. And the higher the concentration, the cheaper it is to capture that CO2. Just as an example, in 2023, if we captured all the CO2 from biogas, we would have had 29 million tonnes of biogenic CO2, which would have been about 70% of the 2022 demand for overall CO2. Next slide, please. So the report itself is available online. It's free to download on the BIP website. There's a whole load of reports there from all the different task forces. So I recommend anyone who hasn't read it, go and have a look at it. There's also video summaries, and the launch webinar is also available there. So thank you very much for that, and I'll pass on to whoever's next.
Thank you very much, Julian. Next is Reinhard.
Yeah, happy to take over. Let's please start with the first slide. Next one, please. Next one, please. Okay, this one. Yeah, Nature Energy, as Lisa already said, is the biggest European biomethane producer. What does that mean? Roughly 2.4 terawatt hours production per year. Since 2 years, we are fully owned by Shell and currently in the full integration. We are running 30 plants in Denmark, 1 in the Netherlands, 1 in France. Yeah, and there's quite a project pipeline for international projects. What is special about Nature Energy? First of all, we are speaking about sustainable biomethane. So we are only using as the feedstocks, we are only using waste and residues. And this will then also apply to the biogenic CO2 we are producing. It will be from sustainable sources, which is in context with regulation, etc., quite important. Our plants are mainly in Denmark, and those are really huge plants. If you're in the context of biomethane, you can see it here spread over the whole country. We are actually taking a lot of manure into our plants, and to the extent also the agriculture sector is benefiting from reduced methane emissions. Could we please go ahead with one slide to explain what actually big means? You can see here one of our plants. We take usually roughly 1 million ton of biomass. If I'm speaking in tons, you also need to consider that there's a lot of liquid coming in with the manure, and producing roughly 250 gigawatt hours per year of biomethane, such a plant. And why large plants? Yeah, it has to do obviously with economies of scale, but also if you're thinking about how to expand this platform, then it makes a lot of sense to have material available. And in the case of CO2, this means roughly 25,000 tons per year. So just to put this a little bit into the context to what Julian said, to be realistic, how much is this? I think altogether our plants would be for roughly perhaps 300,000 tons per year of biogenic CO2. Can you please go to the next slide? Here we see the circular economy on the left, and this is actually why biogenic CO2 from biomethane makes a lot of sense, because then you are in this short-term cycle of exactly 1 year. In this year, somewhere the cow is doing something, eating something. The residues from the cow and food, etc., are brought then to the biomethane plant, and then the organic waste is brought back to the farmers, and this means that within 1 year all the CO2 is in one cycle, so then accounted to zero. If you compare, for example, for wood, it's also a little bit more difficult. Then you have to speak about 100 years. So actually a rather good platform, especially if you look at the outputs. There are several outputs. There's biomethane, and to start with this, if you are just doing biomethane, which means taking the biogas produced in the plant, separating the CO2, and then feeding in the biomethane into the grid, we are just using 40% of the biogenic carbon. So biogenic carbon has actually this advantage of not adding more CO2 to the atmosphere, so there is always a goal to expand this ideally to 100%. So what is the next step? This is a biogenic CO2 that is here in the second row, and there's moreover other stuff to come. There are fibers, then you can think about pyrolysis, etc. But if we go with the biogenic CO2, then we are already at the 55% of usage. What can we do with the CO2? Actually, we are rather agnostic what to do with this. There are several pathways. One could be direct usage. I didn't actually add it up here because our experience is that there's not much really interest or price willingness in the classical CO2 sectors. So that's why I added here CCU and CCS. Let's start with CCS. This is very much currently a very dynamic topic in Denmark. In Denmark, there are tenders around actually to capture this CO2 and then to put it into CCS, and the first deliveries should start in 26. So that's happening quite something, and so what we think in Denmark currently, there's a strong pull for biogenic CO2 into CCS. Then let's talk about CCU. CCU for me means now to use the biogenic CO2. There is a lot, in theory, there's a lot of stuff around, could be biogenic chemicals, etc. But what is currently the most realistic one, that's the e-fuel production, and we are already running an e-methanation 6 megawatt project in the south of Denmark. We never investigated this, but I think it's actually the only project of this size currently running in Europe for e-fuels like e-methane. If we flip to the next slide, the last slide just showing what we are doing there. You can see on the top the classical biomethane production with the digesters, and the output is methane and CO2. Then we have an electrolyzer. This is built by a partner, Andil. With the electrolyzer, we are producing hydrogen. The hydrogen is then, together with the biogas stream, getting into a reactor. There are trickle filters, and there are bacteria, the same bacteria who are doing the anaerobic digestion, who are converting then the CO2 in presence of H2 to CH4. So a rather simple process, not a catalytic reaction. Advantages are less energy demand, rather cheap, and very low requirements on purity. So we are actually taking this CO2. Julian explained a bit about the composition. So all this, the bacteria like it, and then this is converted into so-called e-methane and fed into the grid. What are currently, after 1 year running, the learnings, and perhaps also as a hint to others who are interested in doing this? Well, electrolyzers is still a topic. To get this into stable operation is a challenge. Methanation is running fine, but there's also something important to know. If you do something with hydrogen, well, it's very likely that there is still some hydrogen in the output, and Denmark has a very strict regulation on having only 0.2% of hydrogen when fitting in this into the grid. Other countries have 2%. And why is that a problem for us? It's not our idea to run really baseload or something like this. It's very, very clear that electricity prices are on rather high levels, so we can only run in individual hours and optimizing this against the market. So the more flexible we are, the higher the profit is, and at the end also the profitable production. And this is a little bit the challenge around running this really flexible, like some people know this from gas-fired power plants, switching on and off. Yeah, and that is the challenge, the further development. We built this just at the 6 megawatts, already as a sizable demo plant. Full size would be 20 megawatts, and we are running this, to make our learnings and to be prepared once the market started. It's going to start. Yeah. So far about Nature Energy doing our own CCU, but obviously having more CO2 available from our plants.
Next slide.
That's it.
That's it. There's a picture.
We can take a picture always. That's beautiful south of Denmark, and you can see here how it actually looks like.
Many thanks, Reinhard. And then I would like to pass on the microphone to Fabian.
Yes.
From Eternal Power.
Thank you everyone for attending. I'm happy to give some background on Eternal Power as an off-taker in this field. Maybe Lisa, could you switch to slide 3, I guess?
This one?
Yeah, one before this one. Yeah, the question here was basically why does Eternal Power need biogenic CO2? We are a global acting mass producer of green hydrogen and derivatives. Actually, with 3 projects. Of one is an e-methanol project very far north in Sweden. We are developing that project together with 2 partners in that consortium. One is a wind farm and one is a engineering consultancy. And yeah, obviously to produce e-methanol up there, we need biogenic CO2. So the project will produce 300,000 tons of e-methanol from year 29. We'll have COD, and yeah, will be used for chemical industry. So we got offtake term sheets with chemical industry and fuel producer for eSAF, for green jet fuel. And yeah, that's basically where we need the biogenic CO2 for to have compliant e-methanol available for these further productions. And you can see here the demand. I think that was already properly covered by Julian. I won't address this, but yeah, on the and also I think we had some information on the cost comparison here. So yeah, we get direct air capture, which you can see is a very expensive way to produce biogenic CO2, and when it comes to or CO2, and when it comes to biogenic CO2, yeah, we're working with the high demand that we have. Actually, we focus on the paper industry. As I said, we are producing in Sweden 300,000 tons of e-methanol, which equivalents roughly with 400,000 tons of CO2 that we need for that production site. So we need massive sources, biogenic CO2 sources, and that co-located to our production facilities. We go to next slide, please. Yeah, how do we approach the offtake market, or let's say the biogenic CO2 market, and that I would say it's obviously for us, it's all about identifying locations that have a significant CO2 source. Obviously in connection with all the other prerequisites that we need to establish a production plan for e-methanol. That means large power sources nearby, so hundreds of megawatts. Green power sources are embedded into our production. We need the right grid access capacity, so massive grid availability. Obviously, the right amount of water sources. Pretty significant industrial land, let's say 20 hectare plots with high permission potential, and so it's very, very tough to identify these locations where you have all prerequisites. There are only, as we've scrolled through Europe, we've identified this project and one more in Portugal that we're actually starting to develop, that can be competitive when it actually comes to what the offtake market can accept. Yeah, then we could go to next slide. Yeah, so we've touched we've touched basically the CCU capture cost. We see that somewhere, and that I think was also part of Julian's presentation. We see that between, say, 40 to 80 euros a ton, and yeah, we've from our side, we're addressing the market, so to say, I would say there is no price level as there is no established market at this point. So what we do, we basically calculate back from what our off-takers are willing to pay. And there is for e-methanol, I can say there is let's say there's obviously from industry to industry. On our off-take side, there is a let's say a willingness between 1,000 and 1,400 euros per ton for the e-methanol. X-Works, and then basically we can in our financial model we basically can offer to the CO2 supplier what matches as a price what matches our financial planning and obviously the need for a specific IRR of such a project to get to bankability. So basically, the CO2 price, I couldn't really speak about a market. I can only, say what we can potentially offer, maybe like 80 to 100 euros per ton is what we can fit into our cost breakdown to get to bankability for the e-methanol production, and that's the basis for that. So can you go to the next slide, Lisa? Yeah,
Fabian, sorry,
Yes.
just because we're of course late as always. Can you just because we would like to have a
Speed up.
little speed up.
Yeah, we can basically we can kind of skip over this slide. I think the question kind of obviously where we see the potentials and challenges is something we can discuss in the group here. But I think Eternal Power will support like the ramp up of the biogenic CO2 market by adding maybe looking at our pipeline that will hopefully proceed as it is by adding 400,000 tons of demand every 3 years, as said, based on what is capable on our offtake and when it comes to our offtake partners, as described. Thank you.
Thank you, Fabian. Okay, super. Thank you so much for your presentations, informations about your activities there. I will stop sharing my screen. And is it stopped the sharing? I don't know if it worked. Yeah, it should work. So and let's have a discussion on what you just said. Super interesting. I'm very curious. I mean, it's crazy what you just said, Fabian, with the location, which needs to cover grid connection. You need water, space. You need feedstock. You need the CO2 to be able. You need transport also. I guess you need to be close to oceans. How do you, and this is a question for Reinhard, at what point did Nature Energy start to think about biogenic CO2 as a product which can be traded, which should be captured and utilized?
But I think we have to be careful when we are saying we are already having this product. I think there is a good chance that this is going to be the next product on the biomethane platform, but it's still very much in the beginning. One has to admit the buyers we find in the classical market, and this is actually where we had the first project already a couple of years ago, I think 2017 at one plant, where we have a industrial gas company on our side who are liquefying and selling it into the classical market like food. But we only did it obviously on one plant, and the reason why is very well, if one could earn good money with it, it would have been everywhere. But this is simply not the case. in that time, yes, it was the idea to have it as an additional revenue stream, but actually not that much about the CO2 price, because what we are doing there is we are selling it as fossil. So we can take this replacement of other fossil CO2 gas into the greenhouse gas value calculation of our biomethane. This was a driver there. So actually it's not that much that the CO2 market seemed to be a very attractive option. But somehow this is obviously changing now, especially in Denmark with those projects around CCS tenders, the interest obviously to create CDRs from BECCS. That is driving this, and you already see quite a lot of biomethane plants. You can see those expansions to CO2 liquefaction. Biomethane producers getting active in that market, and that's where we are as well. We are looking into business cases to see what allows us to establish a business case with the CO2 liquefaction. And why am I mentioning the liquefaction? Yeah, that is actually the crucial cost driver.
Okay, I see. Can you say anything about cost for liquefaction as opposed to having it not liquefied?
But it's actually hard to say, because it's also, if you look at our plants, you would end up at different costs depending on the upgrading technology. Yeah, how pure is this? What technology we have? What CO2 quality then? So it's very difficult to say actually.
Yeah, okay, I see. Okay, and coming back to the quality of and this is a question for all of you, coming back to the quality of the biogenic CO2. I mean, different feedstocks of the biomethane would create a different, please correct me if I'm wrong, would create a different quality, purity of the biogenic CO2, which then defines if you can use it for e-methanol, if it's better for e-methane, or in which industry you can use it. So how to deal with that as a producer, but also as an off-taker. And Julian, of course, if you have some thoughts about that, would be great.
Yeah, I think the quality of the biogas will be determined by the process, but it's generally, as a rule of thumb, we'd say that biogas is 60% methane, 40% CO2, and there's slight variations, but that's the rule of thumb. The upgrading technology will produce, 96 to 100% CO2. The focus up to now has been producing quality biomethane as opposed to producing quality CO2. And I think the emerging technologies they'll focus on both. The higher the purity of the CO2, the less energy that's needed to liquefy the CO2 and have it available for the market. So there's definitely an interest for the industry in being able to produce your biogenic CO2 at 99+% coming out of your biogas upgrade technology. Because at that stage, the liquefaction of CO2 can actually be relatively low cost. And then you've got the distribution, which of course you're going to have, no matter where your CO2 comes from, it's going to have to be distributed to wherever it's needed. So. I
mean, definitely, it's if you do liquefaction, then you have the transport issue, and then the technical specification about the purity is rather clear. Because no logistics company would take something which does not comply with the well-known AGA standard, for example, because then they need additional trucks or whatever. This is simply wouldn't happen. So you have to do this on your site before you do the liquefaction, and with the liquefaction, it's pretty clear which standard you have to reach.
And I think that there's a great opportunity emerging in transport of non-food grade CO2. I think the existing supply chains are very clear. They only really want to have food grade CO2. But certainly, I mean, I'm only familiar with the UK market for that, and there's already companies that have put themselves into the market for transporting CO2 from biomethane upgrading. So it'll be I think that will emerge. As I mentioned in my talk, it's, the existing formal market's about 4 million tons. It needs to become an awful lot bigger than that And I think the rough idea we were giving costs of about 10 cents per kilometre per tonne. So, you know, that's, you know, in terms of transport, it's you know, it's a cost, but you know, to be able to produce, you know, do a round trip of 100 kilometres for €20 per tonne, it's not again, compared to direct air capture costs, it's still in the relatively cheap terms.
Yeah, for us as a producer of e-methanol, we can only be co-located because the transportation of CO2 over long distances wouldn't allow us to be competitive.
Yeah, I think this is a point, and what I've shown is that we are co-located with our own e-fuel plant. Then the things are changing around, because then it's not about the logistics, then it's also not about the liquefaction. And also, yeah, in our case, actually, we don't need any purification. We are just taking the biogas as it is, and there might be other use cases around mineralization or whatever. And if you're then co-located, yeah, then it looks differently. Yeah.
Okay, thank you. And you mentioned food grade CO2. Can you elaborate on that? Is that a certain quality requirement?
This is one of what I consider a bit of a red herring within the industry. So there's a lot of focus that the high value market for biogenic CO2 or for CO2 is to make it a food grade product, and that's where everybody should be focusing. I've heard various conversations on this in relative terms, and certainly relative to the potential of the e-fuels market. The food market's very small. It's also an inherent risk to the biomethane industry in that all we need is one negative event related, you know, traced back to CO2 from the biogas industry to have a terribly negative impact on the whole industry. So there will be plants that will do food grade CO2, but I think in general terms, it's not going to be the main thrust of the market. I think that, you know, whether it's for e-fuels or for full carbon capture and storage, I see those as the much more likely end uses for biogenic CO2.
Okay, thank you. Any thoughts on that from Reinhard or Fabian?
I mean, sure, it's about who can afford this. If you are looking at the classical applications like food industry, there's no real incentive for using biogenic, because they can only show it in the ESG reporting, which has actually no price tag, so to say. If you're looking at e-fuels, or if you're looking at CCS and carbon removals, yes, there's a clear monetization pathway.
But I would think, you know, also the food and beverage companies need to decarbonize, and I would think that it's actually the easiest to put that additional cost to the end consumer
No, you are right, yeah, no doubt, but it's also, I mean, if you look which are the ones who can afford paying for this high price, then you are looking at sustainable aviation fuels with potentially very high mandates. Yeah, and if you speak with the industry also about other biogenic raw materials, etc., there's always the feedback, okay, if it comes to a certain raw material, and I'm not just speaking about CO2 now, if it also goes into sustainable aviation fuels, then it's by far more expensive than the classical solution. Yeah. Usually 5 times the price, and then they are out, yeah, because they cannot pull it over to the end customer. Yeah, so it's not that easy, I would say.
Yeah, of course. Okay, and sorry, did somebody want to say something?
No, go ahead.
No, okay. Then my next question would be for Julian again. Could you give us a little bit what's happening in ERGA and in EBA regarding the biogenic CO2 working groups? Can you let us a little bit know when, or is there like a time frame when we can expect something like a certification system?
So I'm I suppose for anyone on the call, one of the members of our group in the BIP was Ergar, responsible for the renewable gases and certification. So one of the outcomes was that they've started a process of looking at certification of biogenic CO2. It's in process at the moment, so I certainly can't give you any prior conclusions or anything like that. But what's become really clear within the process is that there's everyone who's been involved there's a real desire to get some kind of certification across the line for biogenic CO2. From a personal perspective, I think it's not. I'd like to see that in place sometime in the first half of next year, which I hope is possible. But I'm not so familiar with how long and complicated these processes are, and there's a lot of different organizations involved. But it's a really positive step, and as I say, Ergar were involved in in the BIP report and everything with very valuable contributions. So it's great to see that work has gone to this next step, and I'm excited by what's going to come down the line.
Yeah, definitely. Wow, that's very soon. I'm happy to hear that.
I mean, definitely, it will make, for example, how to describe it in a contract, what you're delivering, etc. That would make it much easier. But to be fair, it's not that it's not possible now doing this. There we have the RED in place. RED is having rather clear statements on requirements for sustainability. So you have something to refer to, and this is also happening if you look at Pure Earth, for example, for carbon removals. They are referring to this. But I think it would be much easier if we had the certification in place.
I think very relevant for the sector is the regulatory on the demand side. So now I would put some wine into the wine, saying, there is, as you said, Lisa, there's food and beverage industry. I think it's hard to convince them as long as there's no regulatory. As an example, ESAF, obviously, there's from 2030 the 6% quota in the jet fuel, which is quite a lot if you look to the numbers, and we will contribute 300,000 tons, which will be consumed by a refinery producing green jet fuel. Then this is far away from 6% quota that we'll see. And also on the B2C side that you are referring to when you speak about food and beverage, we have a binding term sheet with one of the largest producers and traders of methanol. And they get loads of interest from, for example, the chemical sector when it's CPG, so consumer products and goods. If you consider like let's say a window cleaning product that we could all buy, that and also the product bottle could be produced with green methanol, e-methanol. And then obviously you can then in the B2C market live with a euro per bottle price premium for a green product. So that's where we see some of the chemicals who are B2C and then getting a pretty pricey e-methanol, highly compliant e-methanol into the market is where we can see the demand is massively, it's really picking up as we can see the time is, we are running out of time when it comes to, let's say, maybe a bigger need of defossilization and also more regulatory around it. So every regulatory that we see coming in will be supportive for the biogenic CO2 market, I'd say.
Mm-hmm.
And this is not guesswork on the Eternal Power side. It's because we are now having three very mature contracts that will turn into binding next year. So and all require more than we produce.
Mm-hmm. Okay. Okay, thank you very much. I would see what kind of questions we got, and I will quickly do one thing for that. So if anyone would like to book a meeting with any of us, please let me know. And I'm opening the chat. So in the methanization stage, do you separate biomethanol from e-methanol in a mass balance or not? I mean, these two CH4 could have different carbon intensities and prices, or do you consider both the same methane?
Who is the question addressed to?
To George Antonio Gonzalez. Could you say something about that, Reinhard?
Well, actually, it's all about mass balancing, of course. What we are doing there, if we are having this biogas stream together with the H2 and the CO2, obviously at the end, we have to define which part is actually the e-methane and what is the biomethane, and this is mass balancing, and this can be done easily via the calculation how much electricity did I have, how much hydrogen did I have, and this is how it's then done also by the system operator. Yeah? The system operator is being in charge of it and then telling us how much e-methane did we produce and how much biomethane.
Mm-hmm. Okay, thank you. What is the from Gerd? What is the transport? The Gerd Decock. What is the transport cost of CO2? The capture cost is quite low. What if the e-fuel plant is, for example, 100 kilometers away? We had the transport cost before. 100 kilometers would make it home expensive.
Yeah, we were in the report. We use that as an example. That 100 kilometers away is a 200 kilometer round trip. For liquid CO2, that's approximately, the numbers we were quoted were about 10 cent per ton per kilometer. So that's 20 euro per ton for a 200 kilometer round trip.
Okay. And next question from Sarah Daniello. What are the current incentives available for the private sector to support the development and implementation of biogenic carbon capture and utilization? Are there any?
What do we mean by private sector? Obviously, if you are talking about fuels in transport, it ends up in a private sector, and then we are about the incentive from RED, where we are talking about the so-called RFNBOs. Fabian spoke a bit about the targets, and there is one kicking in 1st of January. But this is actually a rather weak incentive because those fuels, e-fuels, only have a joint target together with advanced biofuels, and later on in 2030 there's a stronger incentive for this. Yeah. So I mean, this is where it then actually comes to the end consumer. Yeah.
Okay. Do you? But you don't know what, like, okay, the amount of, yeah, okay. Good.
But I mean, actually, yes. Just to explain this also a bit, we are with our e-methane, where we have some volumes already available from the ramp-up phase. Yeah, we are happy to find somebody who would be saying, okay, I'm willing to take it. Also, it's a kind of marketing thing. As long as the RFNBO certification isn't there, there's actually no way to certify this. So it's a very specific product, so to say. Yeah. Yeah, this is actually possible, but we are actually following a very market rational way. We have to do business cases. We have to establish assets, and then we need much more than just some interest to have a certain tariff for a customer. I think in the past there was something around this, especially in Germany. There was, I think, Greenpeace Energy having a tariff called Windgas, something like this, that existed, and then Audi with this project on e-methane. Yeah, there was something in place, but this is actually rather small. So we really need incentives in the market to drive this.
Thank you. Okay, next question from George Antonio Gonzalez Sanchez. If we capture the CO2 from biomethane stream, we reduce even more the carbon intensity of the biomethane itself, right? Then the biomethane is even more valuable, right? I mean, yeah.
Partly right. If this CO2 is captured and stored, right. If this is used in a form that is replacing fossil CO2, meaning it is used instead of this, so less fossil CO2 in the world, until end of 2035, yes, you can improve the quality, the greenhouse gas value of the biomethane. That's right.
Okay, next question from Amir Gasti. To evaluate the efficiency of converting organic waste to fuel and integrate it with the e-fuel production process, are there any studies comparing the most economical and efficient methods? For instance, how does anaerobic digestion compare to methanol production plant when the end goal is to utilize CO2 to enhance the conversion process?
There's certainly work done on the BIP on looking at the cost basis of the anaerobic digestion process. And I think there's a European project called Biometaverse that the European Biogas Association are heavily involved in, which looks at various biomethane related e-methanation stages, and I think I would suggest keeping an eye on all of those areas, certainly from my side. Whether there are studies would suggest academic, or these processes that we're talking about are large, their scale, so it's hard to say. Reinhard, you might know more about this.
I mean, you see this quite a lot about just also posts in social media or in LinkedIn, let me call it the way that you see comparing efficiencies. But yeah, that might all be right, but how decisive is it? If you are speaking about anaerobic digestion, is that you can take every wet stuff, yeah, so it's a form of biomass, which is wet. If you think about gasification, wet is obviously not that good. Then you have to dry it at first, and so I think there's a lot of material around. But if it comes to comparison, we always have to be careful with those silver bullets. Yeah, let's say, okay, this is much better than the other. No, sorry, this is not what it is, because we have different residues, we have different situations, different output interests, and for defossilization, I still stick to decarbonization, although this is not that right. We have to do everything we can do.
Yeah, definitely. Okay, and one last question, because we're running out of time, from Okon Akan Omolabake. Considering the feedstock, what is the potential of wood waste or forest waste? Can somebody say something about that?
Is this in the context of producing biogenic CO2, or in the context of carbon? I suppose it depends on what it really relates to. It would suggest to me that wood waste and forest waste might be more appropriate for pyrolysis technologies and biomass burning, and of course you can capture CO2 at the end of those processes, and then it goes into the same kind of mix. I think important thing in all of these considerations, life cycle analysis is important. In all the discussions that we've seen, people are always focusing on, adhering to sustainability requirements, adhering to laws of additionality, making sure that we're not double counting anything. The credibility of this industry is really important. If we don't get it right from the start, making sure that we're not greenwashing and double counting and all of these kind of things, I think is a really important, it's kind of a really important step to have as a fundamental base at the beginning of everything. Once we have that in place and we have the reputation in place, then the markets for the e-fuels, for the CO2, and for everything can then thrive and flourish, and hopefully with the market supporting that by buying all the certificates for the CO2 at the end of it. So.
Exactly. Okay, thank you. That's very good end words. Reinhard, Fabian, would you like to add anything? Because otherwise I would end this roundtable discussion, because unfortunately we already are out of time.
Just to say, I would end with, biogenic CO2. It's interesting. It's starting. It's working here in Denmark. I would say it's they're starting a lot here from the CCS side, but also from the CCU side. We see those projects here around e-fuels. Yeah, it's a beginning, and curious to see how this is going to develop.
Thank you, Reinhard. Fabian, last sentence.
Thanks to everyone for joining, and glad for any further discussion that might be the result of the discussion here or the presentation today.
Yeah.
So thank you. Also,
thank you for the input and the discussion. Very interesting. It's so exciting. It's just starting, and let's see where we are in 1 year, 2 years, and maybe we will have the same round and then discuss it again. Okay, I wish you all a good day. Thank you for the audience and for the questions, and I hope you all found it interesting, and wish you a good day.
Have a good rest of the week.
Bye-bye.